Hey everyone, welcome back to my workbench. So I did cut a new board for the Tiger learning computer. It's this guy here. Just need to do a little cleanup work. You can see this end doesn't connect to this end, and I just need to hit this with a file a little bit on both sides and then clean it up a little bit. I did order a bunch of right-handed 100,000 spaced header pins, so I'll be soldering those on tomorrow, and then running twisted wires back from there, not using traces. But in the meantime, I am working on my I want to try to develop an analog Atari 5200 controller. This is a boarded, the buttons are too small. Work on a controller from scratch. It's also analog, true analog control, as opposed to the digital control I currently have. So this is just kind of a breakout board I'm working on now. A breakout cable. I'll hook in my 5200 controller I have made already, and I want to look at how the 5200 reads resistance. And it does uses an RC circuit, resistor capacitance circuit, and I think it's at 60 hertz, but I can't. I want to make sure, so I have to hit it with an oscilloscope. The reason that's important is the 5200 used 640 kilo ohm, 640,000 ohm potentiometers for the resistance, and modern joysticks use 5 kilo ohms. So when they're at center, they're right around 2.5 kilo ohms. So I'm trying to figure out, do I need to? In the past, I've just spliced in bigger, literally like glued larger, higher value potentiometers to industrial sized joysticks. I wanted to figure out a way with a common off-the-shelf, kind of looks like, I should have one here. This is just cut out of a controller, and you can see it's got those are the two. Well, this one actually used 10Ks. I could see on the side there 103, it's 10K. It's 10, 10, and 30, so 10,000. In case you're wondering how I knew. This one's a 10K, which is fine, but how modern systems work is when you first turn the system on, it nulls out it just uses a voltage. They put 5 volts on one side, ground on the other, and they read the center pin, which you'll get roughly 2.5 volts. So when you first turn the system on, it goes, okay, it assumes no one's pushing. It's like if you ever accidentally turn your system on, like your PlayStation on, holding your controller over like that, you'll see it's like way messed up. You won't be able to move in that direction. So it's assuming when the system turns on, it's at 0, 0. So it's at center, and it takes the voltage reading there and just scales it off there. So okay, maybe it's reading 2.61 and the other one's reading 2.4, and it'll say, okay, that's my center. And but the problem is the 5200, it actually uses a true resistance reading, and how it does is it puts approximately 4.3 volts on there, and then pulses probably a transistor 60 times a second to pull it down, and it pulls it through an RC circuit. Well, RC circuits, resistance capacitance circuits, have a very defined decay curve. Well, a discharge curve, I should say. So you can't just drop in one resistance for another, but there's something called reactance. Reactance is a combination. Reactance, as the word would imply, the unit is still in ohms. However, it's dependent on the frequency. So you can use a much lower resistance in the circuit, but even though you have much lower resistance, you throw in a very small capacitors, like down the picofarad range, the reactance is actually the equivalent of like 250K, which is about what I'm looking for at the center. So I gotta play with that later. A little too technical for a YouTube video, but anyway, I'm gonna keep working on this cable here, and tomorrow night I will have the right-handed connector, so I can start working on the Tiger Learning computer and give that another shot. But for now, since I had wait, stuff's taking forever to come in, a lot longer than it used to be. Once I get those in, I will start working on that. So which end of the cable is this? I don't know if it's a male or female. Gotta look under the skirt. It's the female end. So this end is the one that's going to be plugged into it. So this is the end. Okay, I'm talking to myself here. Alright. Fill all these pockets. Well, I'm not going to make you watch me fill solder pockets for half an hour. It's not exciting viewing. But everyone, thanks for watching, and tomorrow more learning computer, and if the parts don't come in, then I'll be working on this a little bit more. So thanks for watching.